Hi, I'm Tim McClanahan. I work for the Wildlife Conservation Society on coral reefs. I mostly work in the Western Indian Ocean, particularly on the African coastline. I work on coral reefs from a number of perspectives, ecological, social, economic. And as a result, Jan asked me to present to you kind of a current state of knowledge of coral reefs and the relevance to a hyperconnected world. I hope to be part of your meeting, but I'll be in a remote part of Kenya, and I'm not quite sure what the connectivity is like, so I've decided to record this talk in the hope that if I don't get connected, you'll be able to hear my presentation. Hyperconnectivity is the current state of the world in terms of many issues, and it particularly affects our psychology and the way we look at resources, the way we trade them, and then these have consequences down various levels of human organization. But I think to understand hyperconnectivity well, it's probably best to start at the bottom, to start with ecology, work yourself up to the fisheries, the geographic context, and then the governance, and finally the psychology. By coming from the bottom up, I think you'll better understand how hyperconnectivity is affecting our world. I'll largely be speaking about the Western Indian Ocean. It's the part of the world that I've lived in for many years and been able to work on many different scales, from local reef ecology up to issues of trade and social organization. The thing to remember here is it is sub-Saharan Africa, largely. There can be differences between countries. We have some wealthy countries like the Seychelles and Mauritius, but we have some very poor countries like Mozambique and Madagascar. Tanzania is also fairly poor, and Kenya less so. So that provides some variety of context, and each of these countries has different trading partners and different levels of trade and economic dependency. Most of the trade in this region is with the northern countries, including the United States, Europe, India, and China, with much less of the trade occurring between countries. Nevertheless, there are maritime and environmental agreements between countries. That is an attempt to sort of better organize environmental and trade with their partners. And lastly, many of you will know that this area has conflict, particularly Somalia, but also conflicts in Mozambique and throughout various parts of Kenya. And these conflicts have a variety of consequences, often created by different perceptions of governance and what is the best forms of governance, and oftentimes election periods are key periods of that kind of conflict. One thing about trade to remember is that fish are traded as an agricultural good. They are not considered wildlife, and therefore it creates a different perspective on how people view fish, and also in particular how they're regulated. Yet fish are in fact one of the key controllers of ecosystems. So you have a wildlife treated as an agriculture within a system that supports an abundant wildlife. Understanding the ecology of fish and the effect of fish on the rest of the ecosystem greatly simplifies understanding the human impacts on the coral reef ecosystem. In fact, I would argue that the single metric most important to measure when you're studying coral reefs is the fish biomass. You can break it down to its component parts, but basically the metabolism of fish is a strong driving factor in two things. One, obviously the production of fish, but secondly is also the calcification processes on reefs, so the reef growth, which is a sort of a longer transient dynamic that's often controlled by fish and their feeding rates. So one of the patterns you can see in this data from the Western Indian Ocean is that many things change with the abundance of fish. As you fish down the fish biomass, if you look at these graphs from right to left, you'll see declining fish biomass. You'll notice there are a number of changes, many of them quite rapid, many of them you might call switch points, where there are specific transformations of the reef based on reducing fish biomass. The red points are no fishing areas, closed areas. The yellow have some restrictions, and the green are open access. So you can see that the distribution of these three types of management are often fairly well correlated with the state of the reef. There's some key examples here that are important to remember. For example, when fish biomass drops somewhere below about 300 kilograms per hectare, you tend to get a proliferation of sea urchin populations. They take off and then they begin to dominate the ecosystem, and you end up with a reduced calcification, higher erosion rates, and a loss of that ecological service. So much of that can be understood as rapid changes between dominance of the species important for the metabolism on that reef. If you look at the distribution of this fish stock biomass in the region by nation and by the switch points, you can see a number of interesting patterns. One is that most of the detrimental switch points, the ones that change the ecosystem greatly, are beneath what we call the biomass at multi-species maximum sustained yield, which is the gray band through that graph. A few things change, such as the coral to algal ratio when you're above that level, but once you get beneath that level, in this case beneath around 250 kilograms per hectare, you start to see a number of switches occur towards dominance by sea urchins, a loss of species richness, changes in the calcification of the reef. And so in many cases, your management will want to think in terms of this band of maximum sustained yield, because having stocks above that level will prevent a lot of the degradation in these reefs in the region. If you look at that distribution by country in the region, you'll see that in the presence of closures or marine reserves, much of the biomass is above that MMSY, as would be expected. But some of the other countries differ considerably based on a variety of conditions. For instance, the Maldivians rarely eat reef fish, so their biomass is very high, and most of it is restricted. But if you go to Kenya, the distribution of stock biomass is very much dependent on the restrictions in place, with very low levels when there's open access, moderate levels with some restrictions, and closures having moderately high biomass. And overall in the Western Indian Ocean, you can see management is a very important part of keeping biomass within the context of that maximum sustained yield band. Consequently, if you look at fisheries and some of the basic principles of fisheries, you can have a good way to evaluate the issues around both controlling the ecosystem, because of that importance of the maximum sustained yield, not just for yield itself, but for all the other ecological and biodiversity issues, but also for the yield and maximizing yields in areas that have food security issues and poverty problems. So the growth and yield model, or the MSSY or logistic model, is actually quite important in our region, and something to discuss in a bit more detail in order that you can understand what the consequences of hyperconnectivity are for this region. One of the things I realized when I began working in the Western Indian Ocean was the lack of some key fishery statistics, such as the recovery rates and the final biomass, or K, or sometimes known in fisheries as pristine biomass. So I spent a good part of 20 years counting fish, estimating biomass, and compiling this graph here, which shows the biomass over time in closures of different ages. And this allowed me to calculate two of those important values. That is the recovery rate, which is an R of 0.23, and the pristine biomass, or K, which in the case of closures is around 100 tons per kilometer squared, or in this graph, 1,000 kilograms per hectare. These then can be used in future fisheries models to estimate what the yield potential is. One thing to note here is that you do have to use larger areas, more than 5 square kilometers, and in many cases, if you don't do that, the dynamics are considerably different in these smaller closures. And so many of the current efforts to make small closures are often going to come up with different values, but for the purposes of the models that I use, the values in this model are often this recovery are often the basis for the production models in the fisheries models that I'll talk about. In order to understand hyperconnectivity better, it's important to refresh yourself with some of the basic issues of fisheries economics. That is the maximum sustained yield curve, the hump-shaped curve, and then the fishing effort costs, which is the straight line. So where you end up in terms of the stocks and yields can often depend on the cost of fishing. If you have high fishing costs, in many cases people cannot actually reach the maximum sustained yield. That's often not the problem. The most common problem is fishing costs are considerably reduced. This can be done through lack of opportunity, unemployment. It can be affected by subsidies or reverse taxes on things such as fuel and boat costs. And in many cases, it can include even purchasing gear and boats by the government to keep the costs down. So in many of the African countries where there's poverty, there's often a pro-poor policy in order to reduce costs of poor fishermen. And as a consequence, the stock biomass tends to be driven below the levels of maximum sustained yield. In fact, throughout most of the African coastline, I've estimated that more than 90% of the stocks are below the MSY estimates. And yet subsidies remains as a viable policy in this area and something that's quite contested. The idea of taxing fishing is a policy lever, but it's seldom considered an option in an area where people are considerably poor. Consequently, if you plot some of this information together, recovery rates, yields, estimates of pristine biomass, MMSY in the yellow bands, you can sort of see what some of the options are in terms of the outcomes of different fishing policies. If you stay within the yellow band, your yields are generally pretty high, sort of on the 4 to 6 or maybe more tons per kilometer squared, depending on what the recovery rates are. But for the realistic recovery rates here, sort of a yield of about 5 or 6 tons per kilometer square seems to be realistic. If you drive biomass below that level, you're going to enter into ecological degradation and perhaps not a direct linear relationship with yield. You'll get more ecosystem degradation and potentially some long-term consequences for reducing productivity and other important ecosystem services. An important question here is the extent to which these yield models are good, the extent to which they predict actual yields in specific fisheries. And these are some specific fisheries in Kenya that I've been measuring fish catch at for about 25 years. And you can look at the rates of change in these fisheries and plot them as a function of fishing effort. And what you can see is that they often cross the equilibrium point or the zero change point at values that are very close to what the model predicts for the particular stocks in this region. So the stocks tend to be low, around 25 tons per kilometer squared, and the prediction is that the yields would be somewhere around 4 tons. And in fact, many of the fisheries were higher than that, but over time they declined over the 20-year period to more be in line with those predictions. So the model seems to be pretty good, and it's good enough to consider what the production levels might be, and then the other kinds of consequences that emerge out of those production levels. You might ask yourself why I, as a conservation biologist, am promoting MSY. It's often seen as not a particularly conservation oriented model, but a lot of that depends on what the relationships are between production and biodiversity. And there are a number of models out there, and depending on which model you tend to adhere to or believe in, you'll find different sort of patterns. And in coral reefs, in general, biodiversity increases with fish stocks, fish biomass, but there's often a switch point at which it doesn't increase much, and that switch point is very close to MSY. And it's really only when you pass MSY that you begin to lose a lot of species very quickly. So you can have MSY and get a great deal of biodiversity. And so there's not a hard negative trade-off between yield and biodiversity in this area. In fact, as yields increase to up to maximum sustained wild, you often increase biodiversity and you get a good protection of many species. So that should be seen as a positive attribute of the MSY in terms of conservation. It's not really the MSY model that is the problem with biodiversity or with fisheries in this region. It's really a matter of fishing effort. Fishing effort has been increasing along with population growth, but also with mechanization, motorization of the fisheries. So if you look at effort and you look at the catch per unit effort for the Mozambique channels, you can see these rapid declines in catch per unit effort, often associated with the motorization. And that allows people to access fish at a larger scale and often at a lower cost. And that is often done within the context of promoting yield and promoting food security, reducing poverty, but in many cases it can contribute to the poverty after some time. It may have short-term gains, but long-term negative consequences. So it's really now a time to more think about restoring fisheries to MSY rather than just a pro-development, pro-poor policies that are really pro-exploitation without the restrictions. What becomes increasingly important with stocks now is the geography of those stocks, where they're located. What are the consequences for this overexploitation? Is there the possibility for recovery? And how are we going to move in this direction of MSY? So I spent a fair amount of time trying to figure out the relationships between travel time and stocks. And this is a plot for all of the sites, many sites of the Indian Ocean and the Pacific, where you can plot the stock levels as a function of the travel time. And what you can see is that the distance to markets and the distance to human settlements are major drivers. For human settlements, it's about 4 hours before stocks level off, but to major markets is as much as 9, 10 or longer hours before stock levels level. And this information is very useful for knowing where stocks are and what that might mean for fisheries policies on a large scale, both globally and within more national jurisdictions or county jurisdictions and ecoregions for that matter. An important development in the geography of fisheries and particularly in stocks, particularly in areas with low empirical data on stock biomass and on large spatial scales, is the ability to model stocks in space using machine learning algorithms. So we've done that for the Western Indian Ocean, and this is sort of an example of a recent effort using a random forest model where we find out the partial plots or the partial contributions of a variety of different things to those stocks. And you can see that travel distance is one of the strongest, but water depth, management, some of the biophysical metrics are important, but particularly the nation, some aspects of the nation, probably through its fisheries laws and its compliance with those laws, are important. So this gives us a great opportunity to now look at stocks on a much larger scale than would have been possible before these advancements in technology. The result is that you can model biomass on very large spatial scales, which is what you're seeing here. And then now that we know recovery rates, you can also model the time to recover to, in this case, some low MSY level of 400 kilograms per hectare, so sort of the minimum level we'd like to achieve. And you can see how many years it would take of absolutely no fishing to get to those levels. And you can see in many areas there's these times are considerable, considering that there'd be no fishing involved at all. But this is more of a hypothetical situation. It is possible to recover stocks with some fishing, as long as that fishing has reduced effort and non-destructive gear. You can actually, there are cases where we've been able to recover stocks in the absence of the total cessation of fishing. And that's more likely to be an agreeable situation in this region. I don't want to give you the misimpression that the seascapes that I'm talking about, the ones that are fractured by human usage and have marine reserves or closures, are in fact pristine situations. In fact, if you compare some of the data collected by organizations like NOAA and the National Geographic Society in these very distant locations beyond the 9 hours travel time, you'll see biomass is considerably higher, as much as twice as high as in these more disturbed seascapes. And even if we restore these seascapes to what I call best practices seascapes, which is 70% restricted fishing and 30% closures, the potential to get biomass equivalent to those pristine systems is not possible. They're not going to reach those levels. They will be good as fisheries managed systems, but they will not be untouched or pristine systems. And therefore, knowing where this pristine ecosystems are, where this wilderness is very important for understanding where species that are not protected by this management system are located, and how hyperconnectivity might eventually further erode them unless there are certain management designations put in place. For example, not just considering marine reserves, which is very topical and part of the SDG goals, but actually considering wilderness as an authentic management system that needs special efforts to ensure that we have wilderness. And so what I'll show you here is my efforts to try and estimate where this wilderness is. This is one example of a plot evaluating coral reefs that are greater than 4 hours from human settlements at an ecoregional level. And what you can see is that there is not a lot of coral reefs greater than 4 hours. In fact, in general, most of these areas have less than 10% of their reefs at distances, and particularly along the African coastline, particularly in Southeast Asia and the Caribbean. There are areas in the Pacific and some remote island areas that have more of this type of wilderness, but it's actually a very small percentage of the total ecoregional area. That means you can have whole ecoregions with essentially no wilderness, and possibly none of those species associated with that wilderness. So in many cases we know about that, for example, with sharks, but time doesn't allow me. I could show that this occurs for all kinds of species, many of which you might even not consider, including things like parrotfishes and others. So it's important for us now to think about, in this hyperconnected world, how we're going to maintain at least some wilderness. This wilderness can be extremely important for recovery purposes. Eventually, in these highly exploited systems, they become recruitment limited. What that means is they just insufficient reproduction from many species to get recovery at the rates that we might hope for. If that occurs, then in fact, the estimates of recovery that I've mentioned are probably overly optimistic. And species will be lost and production will be lost. And this is not the way we want to go in a hyperconnected world. This is just an example of, by ecoregions, about the deficit of reefs in either closures and or wilderness. And you can see there's a large number of ecoregions that lack either closures or wilderness. And these are areas that I feel are potential catastrophes. You need this as an insurance. You need that storage of species, biomass stocks, biodiversity, uh, as I mentioned before. And yet, many of these areas where people are highly dependent, there is a severe deficit. This is another example of using this information where we also look at wilderness as a function of human fisheries dependency. So I use a layer of human dependency, with Africa having very high dependency and some of the northern countries less dependency on fish. And you can see now a different way of looking at it, which is what you might call refugia potential, where people can afford to have wilderness because they're not highly dependent on resources, fisheries resources. But where they are, you can see it's still often in the African coastlines, less so in Asia, but also fairly important in the Caribbean. You should have a good idea about the state of the resource and how hyperconnectivity has influenced coral reef ecosystems. And in the remaining part of my talk, I'll talk more about the social, psychological, and governance dimensions of hyperconnectivity, what we can do about it, how people are affected by hyperconnectivity in markets, and what that consequence is for different policy approaches. Policy approaches are in many ways fairly simple for fisheries. It's about restricting something: gear, time, space, species, size, effort. And so the policy arena has to consider those very specific options, but these are very much nuanced by the social organization around these fisheries, whether they have pro-resource positions or pro-exploitation positions, and how those are affected by their relationships with trade and connectivity. These are very important aspects of what the outcomes will be and what policies will ultimately be adopted. An important part of connectivity is the psychological part and the way it affects our ethical or moral views of the world. People that are highly connected in markets often have higher tolerance of harm to others, less consideration of issues of equality and equity, and also the willingness to participate in collective action. However, fisheries are commons, and collective action is a critical part of their management. And some sense of cost benefits, and who benefits and who's harmed by these particular policies is an important part of getting buy-in and participation in any sort of common property resource management system. One of the issues is who makes these decisions as well, and do they have any inherent biases in the way they look at managing commons. This, for example, is an evaluation I did of the literature some time ago, looking at the various restrictions and the number of scientific articles and publications and citations that arise out of people focusing on these different restrictions. And what you can see is there is a very strong bias towards spatial closures. You get high citations and high impact factors or H indexes, and a large group of people focusing on spatial closures. So the academics, the elite, the NGOs, the people involved often in decision making at country level, they do have their own view of things that may not often correspond with other types of stakeholders. And this creates a founder bias, a bias in terms of what we think is most influential in terms of affecting the resource. And yet many of these things are not that well studied. In many cases, it's a bit premature to understand what is, in fact, the best approach to restore these systems. Some of these decisions about restrictions are very dependent on who scales the benefits of these restrictions. This is an example of the difference between resource users and managers. And there are big differences in how they scale the benefits of each of these restrictions. Managers generally scale the benefits of some very strong restrictions like closed areas and reduced effort very highly, and have less difference between those and the other options, whereas resource users might often have the opposite pattern where they see minimum sizes of fish and gear restrictions as highly beneficial, but less so to closures and reduced effort. So this creates sort of the within nation conflicts within people in terms of how to best manage these resources. So depending on where you're getting your information and whether you experience the trade-offs or not, you can have very different perceived benefits. Often that's at the scale of benefits. A national manager might see a benefit at a large spatial scale of the nation, whereas a fisherman is more likely to see the scale of himself and his family and his village. So these scale dependencies and benefits are an important part of understanding conflicts and how you might be able to resolve these conflicts. One of the difficulties of managing the commons is that in the communities that I study, the agreement with a particular restriction can vary within the community. In general, the restriction that people agree on, where there's low variation in opinions on, those are where they perceived high benefits. But in many cases, those benefits accrue from weak restrictions. So you can get a case where you can get high agreement on the easy restrictions, but very divergent opinions when the restrictions become stronger. That's why in many cases you have to enter into these communities and work on the most agreeable benefits, and working on the most unagreeable benefits, such as closures, you can get a strong disagreement, and in many cases you get defection on those ideas and the lack of compliance with them. And then again, you have this problem between a community agreement, that in many countries there is not strong between community agreement on any of these restrictions. There are some countries like Tanzania, but in general, many countries you don't find neighboring villages to have strong agreement on these restrictions. And that can result in between community conflicts. So if you're trying to manage a commons at a very large scale, you'll find that there will be between community conflicts that result in low compliance with any particular restriction, and that's most likely to occur for the strongest and possibly the most effective restrictions from a scientific point of view, but possibly perceived with low benefits at the community level because of the strong trade-offs that they experience. Another important consideration around restrictions is governance, because it's the governance systems that are going to determine the extent to which people feel that these restrictions will be successful. And this is a case on the Kenyan-Tanzanian border where we looked at people's scalings of governance in terms of the Ostrom governance principles, where people were asked to scale the strength of each of those principles. And then their perceived preference for restrictions. And you can see that there's a pretty strong relationship between how strong they perceive their governance and their willingness to participate in restrictions, or the willing to see benefits of restrictions. So in these communities with very weak governance, you can find that those people only agree to the weakest regulations, such as gear restrictions or minimum size of fish restrictions. In the other locations where there's stronger sense of governance, they're more likely to prefer a more diverse set of restrictions that might include marine protected areas or closures, or maybe even effort restrictions. So you have to look at the governance institutions in each of these communities to know what they see as feasible. And that, in general, you can see in general there tend to be two groups of people, and each of those groups has pretty good governance when it comes to governing themselves. They're much less, they're more divergent when it comes to issues of intercommunity governments, cost benefits, and these are often what are creating institutional problems within these communities that make it difficult for them to support restrictions. Consequently, any sort of restoration programs have to consider the institutional strengths and what is achievable with those institutions. You can work within the institutions to build them, or you can accept the weaknesses and work on weaker restrictions. You sort of have those options. Similar to restrictions, the way people scale the effectiveness of their governance is also highly variable. That is, things that they scale high in terms of governance effectiveness are often highly agreeable. People agree on those things. But when you get into other issues of governance institutions that are generally seen as weak, there's a lot of variability. So these mean differences are often belie a more underlying heterogeneity in opinions. And some of that opinion is most strongest, that variation is strongest at the individual level. But when you pull people into roles and then into villages, you might find there's less diversity of opinion there. And that means that if you assume that the roles and or the villages speak for everybody, you would miss a lot of the variability that occurs at the individual level. And in many cases, that individual level variability is where a lot of the lack of compliance comes from. It's a small percentage of the people, and yet it's important to know that because those things can actually undermine effective governance. The cases I've given so far are examples of rural communities in Africa, and it begs the question of how these principles might be relevant across larger scales, or particularly larger urban, rural scales, market influence scales, and the effect of hyperconnectivity economics on the ability to both participate in collective action and manage the commons, and their perceptions of the outcomes of that management. So what I'm going to do is give you an example of a series of questions. We asked people about the management of their fisheries in 38 villages in 4 countries, in which we interviewed 15 heads of households in terms of how they view the effectiveness of management based on a series of collective action questions. What you're seeing here is clustered groups of opinions. These are opinion clusters from those 1,500 households, and this is their level of agreement with statements about the effectiveness of various management aspects of their fisheries. And you can see there's quite a bit of diversity in terms of opinions, some quite positive and others quite negative, and it depends on the question you're asking them. Many people are pro-management, collective community management. They have more critical of the outcomes typically. In fact, so if you evaluate this by a multivariate analysis, what you'll see is there's 3 main axes on which people differentiate themselves. That's the benefits of the management, the reliability of the yields, and thirdly, their ability to influence political decision making. So what we were interested in was how these patterns might vary with other types of factors like urbanization and other issues such as country and some of the demographic issues that you'll see. Here I'm showing you the outputs of a boosted regression tree analysis where you'll see the responses to these 3 axes, to two of these 3 axes. That's on the left, the management effect on people. But what you can see is the strongest factors are in fact the distance to market, that the further people are away from markets, generally the more positive the views they have of the effects of management on people. And the other is human population, that the lower the population, also the more positive the management effects. There are other influences such as age and gear type and etc. But in general, you can see that these demographic factors of how connected people are into markets have a big effect on their perceptions of benefits of collective action. And same is true for political influence. You can see that there's distance to market effects. The further you get away, the more people have influence, and the population size and age seems to have an effect. Particularly elderly people feel their political influence is very minimal. So these give you some sort of indication of how these connectedness influences perceptions, and that these patterns are probably patterns that we may see all over the world in terms of these market gradients and urbanization. And many of them suggest challenges for collective action around commons that need to be thought through carefully, and particularly the application of any particular model of management to particular urban-rural environments. There may be a lack of a single sort of silver bullet approach, for instance, marine protected areas or closures or gear restrictions in specific sites, and those sites may be very influenced by the degree to which markets have penetrated their societies. Before I finish, I'd like to discuss some important issues around forums, and these forums are in many ways a reflection of the amount of connectivity that people have. There's what you might call the public forum, and these are often people that are more knowledgeable about technology, have connections. Those connections exist across larger scales. Then what are people that I call the shadow forum? These are people that are connected at very small scales, often at the family, the village level, and they lack this connection and knowledge of what occurs on these larger scales. Even the discourses, they're often unfamiliar with them. And yet, any kind of resource management of the commons is a commons problem. It's a local problem. It's not entirely local, and that involves many stakeholders and intercommunities, relationships, but in general, it's a commons problem. Consequently, if public forums are controlled by the connected, the hyperconnected, you can expect conflicts with the shadow forum, and I think that's what we're seeing in many locations around the world. The consequences of public and shadow forums is that when you're trying to solve problems on the adaptive cycle, you have two different types of potential forums, one which may be more functional than the other. A particularly dysfunctional forum is what I might call the cycle of shirking. That's where people may interact with each other, but in general they don't have participants from the shadow forum or vice versa. In many cases, those people are patronized. In many cases, discussions often result in conflicts and irresolvable issues around a variety of issues. The other type of forum is a more productive forum, and that's one where there's a very explicit attempt to look for ways to integrate these different kind of perceptions and these different kind of connectivities and the different scales of the problems. And in these types of forums, it's possible to find win-win situations, but these are often the easiest ones. These are the things that we can largely all agree on. There's not a lot of deviation around these problems. And when we enter into the more difficult problems, the ones where there are strong trade-offs, you can find some conflict. But in many cases, if those conflicts are communicated clearly, transparently, and fairly, and it's understandable what the consequences are and what might be the adaptations to those consequences, you're more likely to resolve these kinds of problems. So it behooves us to consider these two options and to work towards the acceptable trade-off condition in order to avoid conflicts. So while I believe that there is a moral imperative to not destroy the means of correcting mistakes, it brings up a number of questions about what are mistakes, who evaluates these mistakes, what do we monitor, who decides how to change these course of actions, and what happens to these unconnected stakeholders that are not connected in this hyper-connected world. Unless we resolve these problems or deal with them in some creative ways, we leave the door open for a considerable amount of conflicts that can just be exacerbated the more hyper-connected that some people are, while others remain less so. Therefore, it's best to see these types of forums and hyperconnected problems as wicked problems. They are wicked problems, because they involve many stakeholders, many objectives, many possible outcomes, and not everybody can be satisfied by any of these outcomes. And in many cases, failure has to be considered a likely outcome and acknowledged as such. So wicked problems are not often evidence-based or best practices. If they are, they're adaptable, as evidence is more about about failure, about evidence of long-term cycles, and a certain amount of honesty about these issues. It's not searching for solutions and perhaps having biases associated with those searches, but and that for it requires many perspectives on inputs in evaluating problems. So it's more inclusive of both a variety of ideas and also the scales of costs and benefits. It seems to me that this wicked problem cycle is really the better solution to the adaptive management cycle. It's unless we do it, we're doomed to both fail and to not acknowledge our failures. And that's not a solution to this hyperconnected problem. With that, I'll finish my talk. My time is up. And if I'm connected, I will be able to answer some questions. Thank you very much.